Today I am going to discuss about some few more problems here. Few more problems. This time I am going to tell you that LCM of two numbers. How to find LCM of two numbers. For example, 12 and 24 is there. By the traditional, how we are going to calculate traditionally? What is the formula for this? For example, there is two variables, that is A and B. For example, every time we are going to divide with, we are going to start with two table, right? Two table. We are going to start with every time with two table. Okay, this is for example T. For example, this is T like this. Now, what is the remainders? What is the remainders for what is the not remainder? What is the coefficients for this one? What is the coefficient for this one? This one is 6 and this one is 12. Why I am taking as 2 here? First of all, I am going to start at 2. Is the two numbers that means A and B both are divisible by 2. I am going to check here, is both numbers are divisible by 2, then I am going to divide it. For example, if both numbers are not divisible by 2, then I am going to take that T plus 1. That means I am going to check with 3. If the two numbers are not divisible by 2, the 3, then I am going to check with 4. Okay, but here the two numbers are divisible, exactly divisible by 2. That's why I am going to divide it. The next one, again I am going to check with 2. Is it possible? Yes, it is also possible again. Yes, 6 and 12 also divisible by 2, and this is going to be 6. Now I am going to check is the two numbers are going to divisible by 2, but this is not possible, right? That's why I am going to increment the value with 3. Now I am going to check is 3 and 6 is divisible by 3? Yes. Now it is going to be 1 and it is going to be 2. Now again I am going to check with 3. That is not possible. Why? Because if any of these numbers, that means if any of these numbers A and B is greater than T value. What is T value now? T value is 3. T value is 3, A value is 1 and B value is 3. Any one value is greater than T, is less than T value, then we have to stop the loop. That means why we are stopping the loop? Here there is no need to, this 1 and 2 are not divisible by, both are not divisible by 3, right? That's why there is not possible. First of all, these are small values. These are at least one value is smaller than that T value. We cannot divisible, right? That's why we are going to stop here. How many steps it is going to be take? Just observe. Here it is going to be take 1, 2, 3 steps. Okay. For all the two numbers, it will take only 2 numbers, only that 3 steps every time. For example, I am going to take one more, for example 64 and 96. Again I am going to explain with one more example, that is going to be 64 and 96. Help me now. If I am going to check is the two numbers are divisible by 2 or not. Yes. Now what is here? 32 and here 40. Not 40.
8, sir.
Here 48. Again I am going to check with 2 here. Is it possible? Yes. This is the both numbers are divisible by 2. That's why this is going to be 16 and this is going to be 24. Here also, again I am going to check with 2. Is it possible? Yes, again both numbers are divisible by 2. That's why this is going to be 8 and this is going to be 12. Again we are going to check with the 2. Yes, this time also both numbers are divisible by 2 here. Then this is going to be 4 and this is going to be 6. Again it is going to be all the numbers are divisible by exactly divisible by 2 here. That's why here it is going to be 2 and it is going to be 3 here. Just look at here. Exactly the two numbers at least one number is less than or equal to. If one number is less than or equal to, one number is at least in these two numbers one number is less than or equal to, what is t value? T value is 2. Then we have to stop it. Then we have to multiply 2 into 2 into 2 into 2 into 2 into 2 into 3. Then this is the multiplication. For example, 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 32, 64, 64 into 3. Output is 64 into 3. What is the output? 64 into 3.
192.
192 is the output. That is the LCM for 64 and 96. Okay, like this we are going to. Yes.
Sir, in the above examples, how we getting in the last three above examples, sir?
Last value. We have to
Yes,
multiply all the values and the last values also.
No,
Where
sir,
we
sir.
have to
First example.
First example. Okay.
Yes, sir. Sir, in last we getting 3 now.
Here.
No, sir. Below.
Here.
Yes, sir.
Here we are going to check. That's it. Nothing else. Here I am going to check is what is t value. T value is 3. Either one value is less than or equal to t. Yes, right. Then we have to ignore it. There is no 3 at all. 2 into 2 is 4. 4 into 3 is 12. 12 into 1.
Okay, sir.
12 into 1 is 12 into 2 is 24. 24 is the LCM. There is no 3. I am going to check. That's it. Here I am going to check with 2. Either at least one value is less than or equal to 2, right? That's why I am going to stop here. I am not considering that number. Okay.
Okay.
Now I am going to write here. Just mute your call. First of all, I am going to read 2 inputs. That means A comma B. Okay. And table. I am going to every time I am going to start with t is equal to 2, right? That's why I am going to give the value t is equal to 2. Where I have to start every time, I am going to start here at 2 always, right? That's why I am going to take 2 here. Again, how many steps here? 1, 2, 3 steps. Here 1, 2, 3, 4, 5 steps. Is the iterations are fixed here? For all the numbers, is there any fixed steps are there?
No, sir.
No, not at all. Then which loop you have to go?
While, sir.
While loop we have to go. Okay, that is clear. Percentage D. I am going to read 2 numbers. I am going to read 2 numbers. That is A and that is B. I am going to write here. The LCM is equal to LCM of A comma B. LCM of A comma B. I am going to take some result is equal to I am going to print this the comma result. This is the main function. That's it. Nothing else. Here I am going to pass one more. There is no need to take. I think to here. I am going to take in the function call. No need. Here I am going to read 2 values. 2 values. I am calling one function and I am printing the result. That's it. Nothing else. Just observe the function call here. Just observe the function call. What is the name of the function? The name of the function is LCM. How many arguments I am passing? 2 arguments. The data types of 2 arguments is integer. And is the function is returning anything? Yes, the function is returning the integer value. Integer value I am going to take here as integer. Okay. This is also integer. That's why we are going to declare in the integer part. This is the function call. This is the information from the function call. Now I am going to write the return type is integer. Function name is LCM. 2 variables that both are integers. One more thing we have to discuss here. That means both are integers, right? There is no need to write here int also. Why? Because if you write like this, it is automatically taken as every value as integer value. By default, it is taken as every variable as an integer variable here. Okay, there is no need to. For example, I am going to check here return 100. For example, a plus b. For example, a plus b. Here I am going to execute it. Just observe there is there an error? No error at all. 10 and 10. The output is 20. That means the both are going to be working as in integers. By default in the function definition, if you are not mentioning the variable name, it automatically treats as a integer variable. But here some problem is there. What is that? For example, if you are mentioning one variable as int, for example, if I am going to execute it, it is giving that error here. Why? Because if you are mentioned for all the variables, that is no problem. For example, I am not giving for B now. For example, if I am going to execute it, unknown type name. If you are going to give the data type for all the variables or no variables if it is integers. Okay, that's why better go to write data type for all the variables. That is the best method. Okay. Now I am going to take that t is equal to 2 here. Now we have to check what I have to check every time. I am going to check is A and B both are divisible by t. If it is divisible by t, then we are going to here I am going to check here every time the A and B divisible by t. If both are divisible, I am going to modify it. Just look at here. If both are divisible, I am going to modify A and B by, for example, I am writing here like this. If A mod t, both the values, right? Both the values. I am going to write B mod 2 is equal to 0. That means exactly divisible. Here like this. By t, not 2 here. It is exactly divisible by 2. Then I am going to modify A is equal to A by t, B is equal to B by t. Okay, that is the values, right? A by t means A by 2. 12 by 2, that is 6. 24 by 2, that is going to be 12. We are going to check like this every time. If both the two values, that's why I am writing here logical and both the values, both the A and B has to be divisible by t. That's why I am writing here AND operator. Okay, I am going to check exactly divisible. The remainder is equal to 0. I am going to modify A is equal to A by t, B is equal to B by t. The new values. I am going to check with 6 and 12. That's why I am going to modify the values. Just observe here, and every time if the t is exactly divisible by the A and B are exactly divisible by t, then I am going to store these values. 2 into 2 is 4. 4 into 3 is the 12. I am going to store the values, right? The left side values 2, 2, 3. In this example, all 2s I am going to store in a particular way. That's why I am going to take here some result is equal to 1. Why I am taking result is equal to 1 here? Why I am taking result is equal to 1? First of all, result is equal to 1. 1 into 2. 2 is going to be stored here. If I take 0, it always 0. I am multiplying, right? That's why I am taking as a result as 1 here. Result into t. Okay, every time I am going to write here result is equal to result into t. Okay, result into t. Every time I am writing like this. Result is equal to result into t. Why? Because if both the numbers are divisible, I am going to store these values 2 into 2 into 2 into 2 like this. For example, just observe here. If both the numbers are not divisible by t, what we have to do? Anyone? If both the numbers are not divisible by t, then what I have to do?
T plus plus.
I have to increment it. That means in the else part, I am going to increment t plus plus. Yes, that's it. Nothing else. I have to write this part for all the numbers. Right? For all the numbers, I am going to check here. For example, I am going to put in a while loop. All this program into a while loop. Where I am going to stop? Where I have to stop? Where I have to stop? Where I have to stop? What is the condition? Where I have to stop? Where I have to stop? Anyone? From this one and this one. Where I have to stop?
If one number is less than another number.
Less than or equal to. Okay. Now I am going to write here. If A is less than equal to T or at least one number, right? That's why B is less than equal to T. Then I am going to stop it. That's it. Nothing else. Okay. I am going to stop the loop. For example, I am going to print here. I am going to print. I'm going to print what is the result value. What is the result value now? Just observe here. What is the result value? If I am going to stop here, what is the result value? 2 into 2 into 2 into 2 into 2. This is only stored in the result. But what is these values? These values are A and B. A and B. That means I am going to write here when both are if at least one number is less than t, I am going to write a result is equal to result into A into B. Okay, result is equal to result into A into B. That means here 2 into 2 into 3. That means 2 3s are 6, 6 2s are 12. After this, I am going to multiply with into 1 into 2. That is this line here. Immediately I am going to return a result. I will explain with an example. Just don't worry. 12 and 24. Sorry. It is mistake is there. One 24. Output is 4. A and B values are modifying or not. Result is equal to result into A into B. 72. Just wait. I am going to print here. Enter result comma SD comma result. Enter the new line. What is B value? Three and 6. one value is less than, for example. I have to stop here. Okay, cool. Now I'm going to check here. Just less than, that's it, not equal to. That's why that is going to be given error. Here I'm going to declare it. I'm going to explain with two numbers, 12 and 24. Just wait, 12 and 24 are the two values. Okay, just observe here, t is 2 and the result is 1. Okay, the result is equal to 1. Entering into the loop. This is, I am writing here while infinite. I will turn this into the normal loop. Just up to now I am going to take it as a infinite loop. Why? I don't know exactly where I have to stop. I have to stop exactly, I know, but I am not writing here. Okay, I will convert that program into normal program also. Just wait. Up to now I am going to take some infinite loop. In infinite loop I am going to return the statement here. Okay, now t value is 2. 12 mod t is equal to 0, and I am going to take 24 is what is t value? T value is equal to 0, right? T value is equal to 2. I am going to check, is 12 is divisible by 2 and 24 is divisible by 2. Yes, both are divisible by 2. Yes, both are divisible by 2. Then I am going to modify a value is equal to 6 and b value is equal to 12 here. And at this time result is equal to, what is result value? Result value is 1. 1 into 2 is 2. Okay, just observe here everyone. Now observe the new a value is 6 and b value is 12. Okay, and t value is, the t value is 2 only. T value is not modified here. Now in the next step, this part is not executed. Now it is going to be check. What happened is 6. Is 6 is less than 2, or is 12 is less than 2. Both are not true, right? Both are not true. Is 6 is less than 2, 12 is less than 2. This is not true. That's why these lines are not executed. Then it is going back to the loop again. And now here a value is 6 and b value is 12. Is both numbers are divisible by 2 or not? Yes, both numbers are divisible by 2. Then we are going to modify it as a 3, and it is going to be 6 and 2 into 2. First of all, 1 into 2 it is, now into 2 again. Okay, 2 into 2 is equal to 4 now. Okay, now again it is coming here, is less than 3 is less than 2 and 6 is less than 2. Is it possible? No, not at all. Now also it is false. Again going back here, now it is going to check 3 is divisible by, and 6 is divisible by 2. Now this condition is false here. Is the 3 is not divisible by 2, right? That's why this is logical and this line is not executed. Okay, one statement is false and the remaining statements are not executed in logical and. That's why it is going to be check here. Is 3 is divisible by 2? No, not at all. This is false. Then automatically it is going into the else block and t becomes 2 plus 1, that is going to be 3 here. Okay, then again it is going to be check, is 3 is less than 3 and 3 is less than 6 is less than 3. This is also false and this is also false. 3 is less than 3 and 6 is less than 3, both are false. Then it is moving now here. Now the t value is 3, right? That's why it is going to be compared with like this. Yes, 3 is divisible by 3 and 6 is also divisible by 3. Then it is going to be 1 and this is going to be 2 here. Now I am going to multiply with 3 here is equal to 12. 4 3s are 12. Now it is coming here, and now what is A value? A value is 1 and B value is 2 here. Look at here. Yes, 1 is less than 3. 1 is less than 3. This is true. If it is true in the logical OR operation, it never checks the next statements, right? If one statement is true, the total statement is true, then coming here. What is the result value? Just observe what is the result value. Result value is 12. And what is A value? What is A value? A value is 1. What is B value? B value is 2. Then result is 24. It is returning the result 24 to the this one. And I am going to print the result is 24. Okay, is it clear everyone? Clear everyone? Just note down here. Now I am going to if you have any doubt, just ask. Students, can I explain with another example? Anyone? Give me the example in the chat box, in the WhatsApp group also. Give any other example. I will work on that example.
Sir,
Yes.
A value, B value మారుతుంది కదా సార్ లూప్ లో ప్రతిసారి మరి T వాల్యూ మాత్రం మల్టిప్లై చేయడానికి అన్ని వాల్యూస్ ని ఎలా స్టోర్ చేసుకుంటుంది సార్ 1 into 2 into 2 into 3 మిగతా వాల్యూస్ ని ఎలా స్టోర్ చేసుకుంటుంది సార్
Okay, I will explain with another example. Just listen carefully when I am teaching here. Okay, just wait. I will explain with another example. Example. For example, 26 and 58. What is the T value? T value is 2 and the result is going to be 1. Okay. Now, this is the while infinite loop and coming inside the loop. Initially, what is the T value? T value is 2. Okay. Initially, T value is 2. The result is 1. Okay. Now I am going to check is 26 is divisible by 2 and 58 is divisible by 2. Is it possible or not? Is it true? For example, I am going to check like this. Is it true? Is 26 is divisible? Yes, it is divisible. Then what is the value here? For example, I am going to take 28 for it will be take some clear examples. It is going to be 14 here. And what is this value? This is going to be 59. 29 here. 29. Is it 29? I am going to take some 60 here. It will be better for you. Then it is going to be 30 here. Okay. If 28 and 60, 28 and 60. Just look at here. Is 28 is divisible by 0? Is divisible by 2? Yes. Is 60 is divisible by 2? Yes. Now I am going to modify A value and B value. Just look at here. A value and B value. Okay. I am going to explain here also. $28 and 60. Okay. New values are, this is going to be 14 and this is going to be 30. Okay. Now again I am going to store this value into the result. This value into the result, right? That's why I am writing here. Just look at this value. I am writing here result is equal to result into t. What is the t value now? Just reply me. What is t value now?
1 into 2.
1 into 2. 1 into 2. Okay, that means it is going to be 2 here. That is 2. 1 into 2 is not storing. The 2 is storing. Okay. Now the value is the result value is 2 here. Why? Because both the numbers are divisible by 2. That's why I am storing the result is also 2. Okay. Now the else is not executed and here it is coming and is 28 is less than 2 or is 28 sorry 30 is less than 2. Why I am taking 28 and 30? The A value and new value are modified, right? Here I am going to take 14. Okay, 14 and 30. 14 is less than 2 and 30 is less than 2. No, this is not true. This is also not true and this is also not true. That's why these lines are not executed. Okay, is it clear up to now? Then it is going back to here. Infinite loop, right? Then again it is going back here. And now what is new A value? New A value is 14 and this is going to be 15. Sorry, 30. Sorry. 15, 14 and 30 here. Now I am going to check is 14 is divisible by 2? Yes. Is 30 is divisible by 2? Yes. Now moving inside again. And now this is 7. Okay. And now what is the value here? 15. Now again I am going to store 2 into 2. What is the t value now? T value is 2 only. T value is not modified. T value is 2 only. Now the result is equal to 2 into t. What is the t value? T value is 2. Then it is going to be replaced with 4 here. Okay. Then it is going to be replaced with 4 here. Now coming here. Now what is new A value? New value is 7 and this is going to be 15. Okay. Is 7 is less than 2? No. Is 15 is less than 2? That is also no. That's why these lines are not executed. And going back here. And now is 7 is less than and is 15 is less than 50. Is 7 is divisible by 2? No, not at all. Then this line is not executed first of all. Okay, why? Because this is the logical AND. If one statement is false and other statement is false. Here this is not possible. If it is not possible, then what is the L spot here? L spot is t plus plus. Then I am going to increment t to 1. That is 3 now. What is t value now? T value is 3. Now it is going to be 3 here and it is also going to be 3 here. Now I am going to check is 7 is less than 3? No. Is 15 is less than 3? No, not at all. Then again going back here. Now what is the t value? T value is 3. I am going to check it again. Is 7 is divisible by 3? No, not possible, right? Then again moving to here, 3 becomes 4 here. What is the t value now? T value is 4 now. T value is 4 and I am going to check here. Is 7 is less than 4? No, not possible. Then going back. Is 7 is divisible by 4? Is 15 is divisible by 4? No, not possible. Then again it is going to increment t value is 5. Now it is 5 is 7 is less than 5? No, not at all. Then it is going back here. Is 7 is divisible by 5? No, not at all. Then t becomes 6. T becomes 6. Now it is going to be checked. Is 7 is less than 6? No, not possible. Then it is going to be checked. Is 7 is divisible by 6? No, not at all. Then 7, it becomes a 7. Is 7 is less than 7? No. This is also no. Then it is going to be check. Is 7 is divisible by, is 7 is divisible by 7? Yes. But 15 is not divisible by 7. Then it is going to be incremented as 8. It is going to be incremented as 8. Now it is going to be checked here. Is 7 is less than 8? Is 7 is less than 8? Is it true or not? Yes, it is true now. Then it is going to be, what is the result value? Result value is 1 into 2 into 1 into 2 into 2. That is going to be 4 here. 4 into, just observe, result into, what is A value and B value? A value and B value are 7 and 15. 7 star 15. What is 7 star 15? 4 into 7 star 15. Then if you observe here, what is the values? 28 and 60. The output is 420. If you want to print the values here, for example, I am going to print percentage D and percentage D, result comma A comma B. Okay, just observe here. Result is going to be 4, A is 7 and B is 15. I am going to print here. What is the T value also? What is the T value also I am going to print. Wait, I am giving some new line here. I am going to give some new line. If I am going to observe here, 28 and 60. Just observe here. Result is okay 420. What is A value? A value is 7. A value is 7, right? A value is 7. B value is 15. B value is 15. And what is the T value at the last? T value is 8. 8 is the value here. If I want the result also exactly after this statement, I am going to print this one. I am going to execute it again. 28 and 60. Just observe here. What is the T value? What is the result value? 4. 4 into 7 into 15 is going to be 420. Is it clear? What is the result? What is the result value? 4 into 7 into 15, right? Yes, look at here. 4 into 7 into 15. And T value is 8. At this position only it is break. Why? Because 7 is less than 8. That's why it is coming out of the loop. Is it understand everyone? This is for just checking. Just for checking, that is just note down everyone. First of all, main program. First of all, note down the main program. If you are not understanding this, again execute it. Execute it. Just first of all, execute it manually. What I am doing here, execute step by step every time. Okay, then you will understand more clearly. Just wait. I am going to convert this manual braking system into natural braking system. That means instead of this one, I am going to write here the condition. Look at here. What is the reverse operation of this one? Reverse operation of A is less than T and or B is less than T. That means A is greater than equal to T. For or I am going to write and B is greater than equal to T. Then the same condition I am going to write here. A is greater than equal to T and B is greater than equal to T. Okay, now I am going to deleting these lines. outside the loop I am going to write now. Outside the loop I am going to write it. I'm going to execute it. 12 and 24, the output is 24 like this. Okay, that's it. The manual braking system is we have to convert manual braking system into natural braking system. We have to write quite opposite. That's it. In the manual braking system, it is going to be less than a t, or b is less than t, right? The quite opposite for this one is a is greater than equal to t. For or I am going to write a logical and. For less than I am going to write greater than or equal to. That's it. Now it is going to be clear, everyone. Note down the main program first of all. Note down the LCM function now. Write that comments also. Write that comments also. Just note down all the comments here. With the example of 28 and 60, what I am doing here. You have to apply the same logic. Just take two numbers again with your own numbers and try to write all these lines. Okay, try to write all these lines. First of all, we have to check any numbers like this. First of all, manually what is the LCM of two numbers and apply here the algorithm. The same algorithm what we are learning at third class or fourth standard. The same algorithm, the same implementation I am done here. What is the difference between mathematics we have done at small standards, and now what is the difference between that one and this programming means every small thing we have to mention in programming. Okay, just look at here, just look at we are taking a small example at 12 and 24. Directly we are going to take it as a t, that variable we are going to check with the 2 defaultly. How we know? Yes, there is no possible with 1 or 0, right? 1 is divisible. Yes, both numbers are divisible by 1, right? That's why we are taking it from 2 here, right? We know everything. That's why we are going to mention here. We have to start at 2. Okay, we have to start at 2. That's why we are taking t is equal to 2. We have to mention each and every point. That is the difference between normal mathematics and here. We have to mention it. When we are going for mathematics, our mind already knows that one. Okay, that's why we are not assuming t is equal to 2, not like that. Our mind is already know that value, right? That's why what is our brain? We have to implement a brain here. That's why we have to tell that brain, tell that system to yes, take t value is equal to 2 here, and the result is equal to 1 also. The small things, very small things. I am going to store this result, right? I am going to store these results. 2 into 2 into 3 like this. First of all, we are going to take 1. How we take 2 here? If 1 into 2, then it is going to be 2. That's why we have to mention this result is equal to 1 here. There's very small things we have to mention in programming. In mathematics, we already know all these things. That is the mistake here. Why? Because we are learning mathematics from I think it is from last 15 years, right? Last 15 years from your childhood, you are learning mathematics. But programming, just 1 or 2 years. That's why. That is the difference between mathematics, and both are very similar. I think everyone is done, right? I'm going to turn it as GCD. Here I also am modifying the program as a GCD. Okay, everything is same. Everything is same. I'm going to execute it. Twelve and 24. What is the GCD of 12 and 24? 24. 12. Okay. It is going to be 12 here. For example, I am going to execute it. Both numbers are not divisible. For example, it is going to be 11 and 13. There is no common factors, right? Only 1 is the common factor for this one. Then 11 into 13. 11 into 13. That is going to be 1 is going to be is GCD. There is no other common factors of 11 and 12. 11 and 13, right? This is the GCD program. Very simple thing. What is the difference between the last program and now? GCD is just observe here 2 into 2 into 3 is the GCD here. What is the table here? This is going to be GCD into 1 into 2 is the LCM. Okay, if you are going to multiply with A and B also, that is LCM. If you calculate only these values 2 into 2 into 3, this is GCD. Okay, the same thing I am done here. I am going to just removing this line, that's it, nothing else. What is this? I just removing this line, that's it. For example, I am going to execute. For example, I am going to execute 28 and 60. If it is GCD LCM, it is going to be 420, right? If it is GCD, it is going to be 4. 4 is the GCD. Greatest common factor for these two numbers. That is going to be 4 here. Okay, just note it down everyone with the small modification, very small modification, that is just removing this line, that's it. Instead of declaring the LCM function, I am writing here GCD, that's it. Remaining everything is same, only just simple one line. Just write it. Removing one line, it is going to be converted into GCD. Yes, I think it is clear. I'm going to explain a small algorithm for GCD, that is Euclidean's algorithm. I'm going to take some different values, that is going to be 24 and 4 and 4 and 52. Okay, I am going to take here two numbers. Just observe everyone. You have to develop this logic. That is, first one is 20. There are two numbers. That is going to be 24 and 56. For example, 56 and 24. Okay, 56 and 24. This is A and B. Okay, this is A. For example, this is going to be B. In our algorithm, every time we have to maintain the two numbers A and B values as a small and big combination. Every time we have to maintain a small number. A value is small, B value is big. Okay, B value is big. Just look at here. Is the two values are maintaining like this? No, it is going to be in a big and small factor. Big and small. Then if big and small is there, I am going to exchange the values. That's it, nothing else. I am going to swap the values. That's it. Okay, I am going to swap the values. Okay, every time we have to mention it as small and big combination only, not big and small. If big and small is there, I am going to exchange the values. Okay, I already discussed about how to swap the two values. Here 24 and 50. Now what is my next step? My next step is A value is okay. Then look at here, B value becomes 54 mod 56 mod 24. Can anyone give me the answer here? 56 mod 24. 56 mod 24. 56 mod 24. The value is 8. The remainder is 8. Okay, that means in the next step A value is 24 and B value is 8 here. Just observe 8 here. Now again the two numbers are big and small combination. Then immediately I am going to exchange it. Okay, again 8 and 24 mod 8. What is 24 mod 8? 24 mod 8. What is 24 mod 8? It is going to be 0. Okay, just mute your call. It is going to be 8 and this is going to be 0, right? 24 mod 8 is 0 and A value is 8. That's it. If B value is 0, A value is the GCD. Okay, if B value is 0, A value is the GCD. That's it. Okay, nothing else. Is it clear? Just note it down, everyone. I'm explaining here algorithm. You have to do it. Again, I will explain with another example. Just wait. 62 and 34. Okay. Again, the two numbers are big and small combination. If the numbers are big and small combination, we have to change it. For example, the numbers are 34 and 62. For example, the numbers are 64 and 32. No problem here. Here there is no problem. Immediately If we have to do it 34 and 62 mod 32. 34. 62 mod 34. The output is 28. Okay. The output is 28. 34 and 28. Is it clear, everyone? And again, these two numbers are big and small combination. I am going to exchange 28 and 34. Okay. Again, 28 and 34 mod 28. 34 mod 28. 34 mod 28. The output is 6 here. That means 28 and 6. Yes, again these two are big and small, then I am going to swap it. And this value is 6 and this value is 28 mod 6. 28 mod 6. This value is 4 here. 6 and 4. Okay. Then again these are big and small combination. I am going to exchange the values 4 and 6. And 4, 6 mod 4. 6 mod 4 means it is going to be 4 and it is going to be 2. And again I am going to swap 2 and 4 and 2 4 mod 2. Then it is going to be this is 2 and this is 0. If B value is 0, I have to stop. If B value is 0, A value is the GCD. Okay, A value is the GCD. The loop, just if you observe, the loop is not fixed. That means we are going for a while loop. No doubt about that. We have to choose a while loop. The loop is not fixed here. This is the example here. And again, I am going to explain with another example. For example, 11 and 13. Okay, I am taking like this. These two values are small and big. Then we are not swapping here. If big and small only, I am going to swap. Now what I have to do? 13 mod 11. Okay, 13 mod 11. If it is going to be A is going to be 11 only, and it is going to be 2. Okay, it is going to be 2, and I am going to swap it again 11 and 2 and 11. Now 2 11 mod 2. What is 11 mod 2? 11 mod 2 is, and this is going to be 1. Okay. Now I am going to swap 1 and 2. Now 2 and 1 and 2 mod 1. 2 mod 1 means 0, 1 and 0. If B value is 0, 1 is the GCD. A is the GCD. Okay. Is it clear, everyone? Students, is it clear? I think this is the Euclidean algorithm for GCD. You have to try it and you have to do it. That is the tomorrow's task for you. And I will explain the same logic in the tomorrow. Okay. But you have to try it. Okay.